What's up, everybody? Hutch here, and this is Module 13, Lesson 3 on rotations. This one is probably the more complicated out of the three we've done so far. And so I want you to really pay attention. I'm going to give you some tips, strategies, patterns, and we'll put this all together to really try to be able to be successful with rotations. So do what you always do. Grind in, dig deep, listen carefully, follow the directions, and take note of every little tip that I give you today. All right, we're going to fill out the math shorts blanks here. It says a rotation describes how an object blanks around a point. Probably rotates around a point. Would make most sense. For this one, though, we're going to, instead of rotates, we'll go ahead and use the word turns, like the video will use. To rotate an object, you first must choose the blankety blankety blank. This is the blank that will rotate the object around. So let's go ahead and we'll watch the video to get that one. When rotating an object around the center of a rotation, you need to keep the shape. You need to keep the shape exactly the blank distance around the point. What do you think? Same. Okay, and we'll see what that means in the video. Last one, the rotated shape is the blank size and shape is the original shape. Just like all the other ones before, we have not changed the size and the shape. It's congruent and also counts as similar. The angles are all still the same. It's congruent because the sides are also the same length. Okay. All right, so let's go ahead and check out the video by clicking the image. You can watch it on here or on your own. Here we go. Math shorts.
Math shorts.
Math shorts.
Rotation describes how an object turns around a point. It's used to describe the movement of geometric shapes. For example, if you tack up only one corner of a rectangular sign, what's going to happen? The sign swings down. It has a rotation around the tack, but geometrically, it's the same shape. Rotation is really common. The triangles that make up spokes on this bike wheel are rotating around the center axle. Mathematicians use rotation to describe shapes on a coordinate plane too. Check out this triangle. In mathematical language, we'd show it like this, which describes the points of the triangle's vertices based on where they're located on the coordinate plane. To rotate an object, you first need to choose the center of rotation. This is the point that you'll rotate the object around. To make it easy, we'll choose point 0, 0, or the origin, on this coordinate plane. When we rotate the shape, we need to keep the shape exactly the same distance, or equidistant, from the center of rotation all the way around. If we rotate the triangle 1/4 turn around the point of origin, counterclockwise, keeping the point of rotation exactly the same, then the triangle moves to a different place on the coordinate plane. The triangle shape stays the same, but the triangle has rotated, and the points used to describe the triangle have also changed. To show that a triangle has rotated, we use a little symbol like this. So now we have turned a geometric shape around a point. That's what rotation means. We can use it to move shapes and describe their movement.
All right, so that's that with rotations. Let's go back here and fill in the blanks. To rotate an object, you must first choose the center of rotation. Sometimes you'll rotate around a point of the shape. A lot of times you'll rotate around the origin. This is the point that you will rotate the object around. All right, so rotation, we know that that just means to turn the object, or you could think about spinning it. First thing, let's go ahead and talk about point of rotation. So the point of rotation is usually the origin, okay, and I would put in parentheses 0, 0, or a point on the figure, okay? So what that means is we could rotate around a point, or we could rotate around the origin. So you just have to read the directions and see what it's asking you to do. All right, direction of rotation, okay? How can you rotate? Well, we could do option 1 would be clockwise around a point or an origin. That's the way a clock goes, which is this way. Okay. Or do you know what the opposite is? If you said this, you would be correct. So go ahead and write counterclockwise. That would be going to the left this way. Okay. So those are two types of ways. A lot of times you can assume that they want you to do counterclockwise. Okay. If they don't mention anything. And that's because on a coordinate plane, the order of the quadrants goes 1, 2, 3, 4. And so you can assume counterclockwise if they just say turn it 90 degrees. Okay. Number of degrees of rotation. So we have some options here. Okay. We could not move it at all, which would be 0 degrees. Okay. We could go 90 degrees. We could go 180, which is another 90. After that, another 90 would be 270 degrees. And then the last one would be 360 degrees. And then let's go ahead and just make a note that 360 is obviously the same as 0. Okay? The other thing to be aware of is if they told you to go counterclockwise 90 degrees, that would be the same as going clockwise 270 degrees. Okay, so there's some overlap with some of those. So let's go ahead and take a look at this. It says describe the rotation with the point of rotation, direction, and number of degrees. Okay, so we got 3 things to do, direction and number of degrees. First one, describe the rotation. Okay, meaning what is the point that we're using. Okay, and so we're gonna, first thing, okay, is we're gonna say this is a rotation around, and then you just say either the origin or what it actually is. So we'll say point A, and let's put the coordinates. So 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. Okay, so we have over 4, up 5, and there we go. So it's a rotation around point A, which is ordered pair 4, 5. All right, next is the direction of the rotation. Well, which way are we going? We can see the arrow, so that's the way a clock goes. And so we would say clockwise. And the last thing says number of degrees. We could say clockwise 90 degrees. Okay. So there we go with that. The opposite to be aware of, okay, is, remember I said it's clockwise 90, or the opposite would be counterclockwise 270 degrees. But because of the arrow, it tells us that we're going clockwise, not counterclockwise. One thing I want you to be aware of, let's go ahead and label this once, is the blue. We can see just a reminder of the words. What's the first image called? Remember, it's called a pre-image. And then the green is our just image, or we know that sort of means our new image. And notice the prime symbols on those, okay, to represent the new image. All right, let's go ahead and do the same thing with all these other ones. You could pause and try them out or follow along with me, okay? So step 1 is, how is it rotating? So we have a rotation around, and what's it around? Looks like point A again. Point A, ordered pair 1, 2, 3, 4, 1, 2, 3, 4, 5, ordered pair 4, 5. Same as before, okay? But this time you can see what direction it's going. The arrow's going to the left. That's called counterclockwise. I want you to write the whole thing out to practice. Counterclockwise. And how many times is it turning? So this is sort of hard. You have to picture almost like a coordinate grid where the point is. And you can see there's something here, and then there's nothing here, and there's something here. Okay, so that's one way to look at to see that it moved. It didn't go to the 90, it went to the next one, which is the 180. The other way that you can look at that is just see that it's almost like a mirror. It's not, okay, because you can see this point. It's not going across a point and ending up here. So it's definitely not a reflection. Don't think it is, but it almost appears like it is. It goes across to the other side almost. So that's a good hint that it's a 180 rotation. So it's counterclockwise, and it went 180 degrees. Okay, let's go ahead and look at the next one. Okay, again, you can sort of see that almost reflection type of thing. It doesn't reflect, okay, because you can see that the shape doesn't actually reflect over onto itself. Okay, so it's a rotation. So let's go ahead and record what it is. So it's a rotation around point L this time. Okay, and that is ordered pair 1, 2, 3, 4, 5. 1, 2, 3, 4. Ordered pair 5, 4. Okay, now what's it doing? It's going to the left, so that's counterclockwise. Okay, I'm just going to save time and snatch this here. Boop. Counterclockwise, and it already says 180 degrees. Okay, I can also tell because of that sort of reflected look, even though it's not an actual reflection. All right, we can already see the degrees. What are we rotating around? We're rotating around this point here. Okay, so let's go ahead and snatch some other writing here. So we have a rotation around point A, and that's ordered pair 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, 5. We're using that point a lot, huh? Okay. What direction are we going? Now we're going clockwise, the way a clock goes. Okay, because it's going to the right. How far? Okay. Again, if you are not sure, I would just draw the coordinate plane at that point, and you can see there's nothing here, so it didn't go 90. There's nothing here, so it didn't go 180. So the third one is the 270. Okay, and so we went clockwise. Sorry, I don't know why I put an X. Clockwise 270 degrees. Okay, so there we go. Or technically, it also could have gone counterclockwise, one movement to the left, 90 degrees. Okay, so just be aware of those relationships, I guess. Okay, all right, so there we go with that. Let's move on to a little bit more difficult, sort of kicking it up a notch here. Okay, so we're going to skip that first part there. Go ahead and put an X through there. This part isn't as wild. I do want you to be aware of a new key concept here. For this one, now we're going to rotate around the origin. And remember, what is the origin? The origin is ordered pair 0, 0. Because remember, when we were talking about is a line proportional, it had to go through the origin and be a straight line. So we've talked about that word before. All right, so 90 degrees clockwise around the origin. You can see the pre-image doesn't have the prime symbols. Okay, so we can see the pre and the post. Okay, just a reminder here, we got pre and green is the regular, is the new image. Okay, so pre-image to new image. Let's go ahead and answer this question. So let's see what happened. It says we rotated around the origin. Okay, describe what we did here. Okay, so we went pre to new, so it went this way. Okay, so that's clockwise, right? Okay, and so we went clockwise. How many grid spaces did we go? We only moved one. Okay, so for this one, we went clockwise 90 degrees. Okay, now what is that also? Okay, if we're going from the origin, one thing I want you to notice is, do you see how here's my origin? And this point is this sort of like one diagonal away each time. Okay, so that's, you can sort of see where that point will be as it rotates around, almost like a bike tire. Okay, so another thing to think about here is if we started here at the pre, okay, and I went counterclockwise, one spot would be 90, another spot, meaning sort of across, would be 180, and another spot would be 270. So another thing that we could say is this would be the same as counterclockwise, 270 degrees. Okay, so getting comfortable with those three numbers of the sort of 0, 90, 180, 270 is really important. Okay, all right. Notice the coordinate notation. We also call this, I want you to write mapping, okay, is what the PSSA might call it. So just be aware of that vocabulary there as well, okay? And so you can see when we moved and rotated this 90 degrees, you can see we went from X, Y, and we then put the Y in this spot, and we put the X in this spot and made it negative. We'll explore that a little bit more, but I just want you to see that mapping. Let's go ahead and take a look at this one. The question is, what happened? Okay, so let's go ahead and look at this. The first thing I can see is we went to the right. Okay, the next thing I see is the first spot would be 90 degrees, right? What's the next one? 180 degrees. And you can see it's sort of going across. It's not a reflection, it's a rotation. I can tell it's not a reflection because of the arrow, and also because if it was a reflection across here, we know that this would be equal distance from there, and that's not the way it's playing out. So it's definitely not a reflection, okay? So I can see what it did. It went clockwise because it went to the right. So it would say clockwise. How many degrees? Well, it's not in the first quadrant, it's the next one. So clockwise, 180 degrees. And what would this be the same as? So pretend we're starting here going counterclockwise. We go one space, one is 90 degrees. Okay, or you can sort of think going left is negative 90, right? And then the other would be 180 degrees, or sort of this like negative 180. So this is the same as counterclockwise, 180 degrees, okay? So either way, whether you went to the right or the left, we're moving two quadrants, okay? That's why it's 180 degrees, okay? So same thing. All right, let's take a look at this. This one is moving 270 degrees clockwise. So what's it doing? Let's just view that now. Here's our pre-image, okay? And we can see, because the arrow's going clockwise, one quadrant is 90 degrees, another quadrant is 180 degrees, and a third quadrant is 270 degrees, okay? So we know that we are going clockwise, 270 degrees. And what's this the same as? Well, let's think about the opposite direction. If this is my first location, and I go counterclockwise, I'm going one spot, which would be 90 degrees, or sort of like a negative 90 degrees, okay? So this would be the same as counterclockwise. That's not an S, that's like a weird squiggle. Counterclockwise, 90 degrees. We don't have to say negative 90. We use negatives a lot in coding to describe a counterclockwise motion, but because we said counterclockwise, it sort of eliminates that negative symbol. Okay, all right, so let's go ahead and explore now. Something I want you to do is hit the page sorter, hit the three dots, and go ahead and create a new page. If you want to screenshot this and put it onto yours, you can go ahead and do that. And then I want you to build this with me. This is sort of going to be your little cheat sheet here. I'm curious if you can identify some patterns of what happens to the coordinates, okay, as you move around the coordinate grid or coordinate plane, okay? So let's go ahead and explore this a little bit. We're going to use the numbers 1, 4. So let's say we had an ordered pair 1, 4, okay, of a point. And this is only around the origin where this pattern works, okay? So here's what's going to happen. We go 1, 4, and I'm going to make a 90-degree rotation. I want you to see what happens. This becomes a 4. This becomes a -1. Do you see what happened? Now I'm going to rotate to 180. This becomes a -1. This becomes a -4. And then when I rotate the same shape to 270, this is -4 and this is 1. Can you see any patterns of what happened? Okay. Which number is staying the same? Okay. So look at this. So I want you to just draw this. When we rotate, the Y goes to the X spot. So we can just say the 4 slides. Okay. And then what happened to the 1? The 1 went over here, but it turned into the opposite. So we have this slide and opposite, slide and opposite, slide and opposite. So it's a pretty cool pattern to be aware of, okay? So if you just had an ordered pair, you could just think, okay, I know what zero movement is, so I can change it to 90, to 180, to 270. And you can just sort of jot through that pattern. You don't even need to draw the shape or the point onto the coordinate plane. So let's go ahead and take a look at counterclockwise. It's very similar. Okay, so we're going to start with the same ordered pair of 1, 4. Okay, and for this one, look at the pattern here. Okay, so this one, what happens is we go like this. 1 goes to here, and guess what happens to this one? -4. Okay, and then let's go ahead and put our -180. Okay, what happens? Okay, so take a look. What happened here? Interesting. Counterclockwise, the arrow just goes the opposite direction. And what happened to the 4? It becomes opposite. Okay, so the arrows just go the different way and the opposite goes the other side. Okay, so what's going to happen here? The -4 goes over there. Sorry, let me use the same color here. -4 goes to there. What happens to the 1? The 1 becomes opposite. Okay, do the last one, -270. Okay, going around. What happens to the numbers? Well, the -1 goes here. And what happens to the -4? It becomes the opposite. Okay, so this is just something I want you to be aware of. If you can remember that, okay, then it's something that can help you solve something without having to draw the whole thing out. Okay, I also want you to be aware of, so think about this for a second. Okay, if we're going 90 to the left, okay, counterclockwise, think about that, okay, this spot is the 270 spot, okay, and do you see how they're the same number? Okay, so those are, you have to think about on a coordinate plane what is matching, what spots are the same as each other as well. So this is something I want you to have. Make sure you have that screenshotted and added as another page so you can go back to that. This is basically giving you the mapping of what happens to the ordered pairs, okay, as they move around a coordinate grid. So let's go ahead and try some of this out. We have triangle DEF has those vertices, okay, and then it's rotated, and they're telling you how it's rotated and what it's rotated around. So the things to focus on is rotated 90 degrees counterclockwise, okay. You could even really focus on this, 90 counterclockwise origin, okay. They want us to write the coordinate notation and the coordinates for the image, okay, so both of those things, okay. So let's go ahead and start by plotting these points. So -4, 4, so we swoop 4 to the left and 4 up. So 1, 2, 3, 4, 1, 2, 3, 4. So here's our first point, and that's D, okay. Our next point is E, is -1, 2, -1 to the left, up 2, and this is E, and then we have -3, 1. So 1, 2, 3, and up 1, and this is our F. Okay, so let's go ahead and connect our points there, lock in those lines, keep everything nice and neat and organized. And there we go. All right, so there's our pre-image. Now let's go ahead and figure out where the image is going to go. So we're rotating 90 degrees, so we know we're rotating one spot, and we're going counterclockwise. So first thing I'm going to do is I'm going to show my arrow that shows that I'm going counterclockwise. And we have a couple options here, okay? The first thing to be aware of is we can use some different tricks too. So I do want you to see this, okay? So trick number one, if you take your lasso and you outline the box here, okay, this particular quadrant, okay, tap it and duplicate it, okay? I want you to see something here. So we can take this entire box, okay, and if you just rotate it 90 degrees, okay, and you place it, but you actually have to rotate the whole box entirely. You rotate it 90 degrees. So we have the original box, and as I let go, you can see I'm not all the way around. All right, there's the whole box, and I'm going to line it back up, okay? So there's the box, okay? I'm going to put that box in my next quadrant and line it up here, okay? And do you see what we created? Okay, we did a rotation. So this is sort of a nice trick. You could also just rotate your iPad entirely, okay, and see where that new shape goes. So I sort of have my points already laid out by doing that trick, which is pretty nice, okay? You just have to be careful and make sure you're being really, really accurate with that, okay? And then we can go ahead and mark them as D prime, E prime, F prime. Okay, so that's one option if you're being really careful and you have that option. But we got D prime, E prime, F prime. Okay, the other option for us to do is to actually use that understanding that we figured out here. Okay, but you can see the rotate plan, if you have Notability, is pretty sweet for this. Okay, or just rotating your iPad and looking at where it would go and looking at those ordered pairs, the new ordered pairs. So let's go ahead and write the coordinates for the image, okay? And I want you to use the trick that we did already, okay? So let's go ahead and write the ordered pairs for our original image, okay? So we have D, E, and F we got to record. So let's go ahead and do D, and it originally was, we can just copy those, -4, 4, okay? And then we have E, already said -1, 2, okay, up above in the directions, and F was -3, 1, okay? Now, I want you to go back up here and sort of think about this, okay? We're going counterclockwise, and we're going 90 degrees, okay? So let's use this to help us come up with the mapping. So we originally were at XY, okay? And then to go 90 degrees counterclockwise, what happened, okay? So this is where we can record what we actually did, right? So this, this went to here, okay? So this becomes X. And what happened to Y? Well, Y goes to here, but it's the opposite. Okay, so we just sort of figured out the mapping of what that would look like. So XY turns into -YX. So let's go down to here, okay, and we can go ahead and record our mapping. Okay, so we have XY turns into -YX. Okay, and this is still the X spot and still the Y spot, but we're just explaining that you put the original Y in the X spot and make it negative, and that's the new ordered pairs, okay? They aren't really Y and X now. It's still X and Y. We're just explaining how to follow out the rule and change the numbers. So you can see now if we're going to follow out that rule, we draw our arrow, D prime, if we're following the map, we have -Y, okay? So this was Y. And so now it's just -4. And we just take the x and we move it over. So we have -4, -4. So let's check D. Is that true? 1, 2, 3, 4. 1, 2, 3, 4. Yep, -4, -4. Okay, so that's how we can follow the mapping. Okay, so what are we going to do for E? Okay, all we do for E, we're going to take, we know our x's are the same, so I'd sort of set this up. -1's going to go there for x, and then our y was 2, okay, and we're going to put the y here as 2, but we're going to take the opposite, okay, and then our last one is f prime. Okay, we know our x's are staying the same, but it is moving, so that's a -3, and the 1 goes here, but it's opposite. Okay, and so that's how you'll write the mapping, okay, and the new coordinates. Okay, so remember again, this is your mapping here. Okay, all right, let's go ahead and try this one. If you want to try this one on your own, you can, or you can follow along. We have an original pre-image. Okay, so let's go and plot that. D is -4, 4. Okay, it looks like it's actually the same pre-image as the other one, but let's just go ahead and plot this. So D is -4, 4. 1, 2, 3, 4. Up 1, 2, 3, 4. That's D. We got -1, 2 is E. -1, 1, 2 is E. And we have -3, 1. 1, 2, 3. Up 1. This is F. Okay. Let's go ahead and connect our points. It's good practice doing this, making sure you can plot points accurately. All right, now let's focus on what they're asking you to do. So we're going 180. What direction? Clockwise and around the origin. Okay. Again, they want the mapping and the new image coordinates. Okay, so same thing we did in the last one. This time, though, we're rotating 180 degrees clockwise. So we know 180 is going to go over here, but remember, it's not a reflection. It's an actual rotation. So we could do the trick of doing the lasso. Okay, and actually, if I do the lasso and do boxed, that'll be way cleaner of a job here. Okay, so I can highlight that like that. We can tap. And then we can go ahead and I wonder, instead of duplicate, I wonder if I copy or convert. No, I don't want to convert. Redo that one. Okay. I wasn't sure what convert was, what it was like convert to an image or something. Let's try copy and then we can paste as an image. That might work better. Yeah, because then you can actually, do you see how nicely you can see that box? Okay. So here's the box. Okay. And then all we have to do is take this rotation tool and look, we can rotate it 90. So there's 90. And remember, we're going clockwise, so put it in the clockwise spot. So there's a 90-degree rotation. And then we rotate it again. Here's 180, but it needs to go in the next box. And there we go. Okay, and if I line it all up perfectly with all the lines, we should be good to sort of leave it there, actually. So it's a pretty cool trick with Notability, okay? So there's our new spots, okay, with a 180-degree rotation, and we went clockwise. So this was the 90, this is the 180. We need to make sure we put the prime marks on here, and there we go, okay? Let's go ahead and take care of our mapping to go to 180, okay? So I would go back up to my little cheat sheet here. Okay, or we could do it without cheat sheet version. Okay, we're going to clockwise, so let's try that out for a second. Okay, so we have point D, okay, and it is ordered pair -4, 4. So what you can do also, let's say that you didn't have the cheat sheet. You could do this temporarily is say, okay, I have a -4, 4. Okay, if I went 90, okay, we're going clockwise. Remember, that's draw the arrow. So 4, and this side's opposite. So now we have 4, 4, okay? And then how do I go 180? Draw the arrow. So we have 4, and opposite is -4, okay? So you can see I have 0 degrees, 90 degrees, and 180 degrees. So it's a way to sort of use that understanding of that pattern, okay? And now I almost have created my mapping. And so from that, I can create the mapping to say, okay, well, I had X and Y, and now I can look down at my 180 to see what happened, okay? So to get to the next one, it looks like the 4 is still a 4, okay? And so we have, this is still, we got to be careful though. I think the best way to do it is always make sure we're not using the same numbers, because it's really easy to lose track of what happened, okay? So let's always don't use a 4 and a 4, use like the 1 and the 4 or something like that. So this is just sort of helping us figure out the mapping. So if I have a 1 and a 4, that then changes to a 4 and a -1. And then I have a -1, and opposite of 4 is -4. So this will allow us to see what actually happened, okay? So what happened in the mapping? Well, I started with x, y, and what did I end up with? Well, it looks like I ended up with a -x and a -y, okay? So you can just look and see what happened to go to 180. And so now we have the mapping figured out ahead of time. Let's say we weren't able to rotate and reflect because we didn't have notability or something. That's another method we could do. So let's go ahead and create our mapping. Okay, so I'm going to write mapping. Okay, so our mapping was, we went from x, y, and to go 180, we're going to end up with a -x and a -y. Okay, and that's all we have to do, which that should be really easy to show those changes. So I'm going to show the change. We have d prime, and -x, or opposite of x, would be 4. And then -y would be a -4. So let's check, is that what d did? Over 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. Yep, it worked. Okay, so that's another method for us. Okay, let's go ahead and do the next one now using that same understanding. So now we can go ahead and take care of E. And we have E was originally -1, 2. And look how easy this is now. E prime, if we follow our map, is just opposite of x, which is going to be 1. Opposite of y is -2. And there we go. And then the last one is F. So we have F originally was -3, 1. Okay, and F prime, opposite of F is 3, opposite of X is 3, opposite of Y is -1. And there we go. We wrote all the points, and technically we didn't even need to draw it, okay? So good strategy for you there, okay? All right, let's look at this next one. Okay, it says use the coordinate notation or mapping to describe the rotation, then determine the angle of rotation, okay? Always assume in this one that it's clockwise, they're telling you, okay? So good to be aware of these things. Describe the rotation, determine the angle of rotation, and we're doing clockwise about the origin, okay? So here we go. It says describe the rotation. Let's find the pre-image. Pre-image doesn't have the tick marks, right? It doesn't say prime. So right here, just be aware, is our pre, and this is our new image, okay? So we're going there. It says clockwise, okay? So I know we're going this way, okay? It says we're going around the origin, okay? So again, look at these here, okay? Is there anything in this section? No, there's not, okay? The other thing to look at is point C from the origin is right here. Remember, this makes like bicycle tires going out. So it's like 1, 2, sort of like 3 out, 1, 2, 3 type of thing, okay? So you can see that we don't have something in this space. This is the 90-degree mark, but we do have it in the next. This is the 180 degree, and they are sort of across from each other, right? Okay, so it looks like we're rotating around the origin 180 degrees clockwise. It does tell us to describe the rotation using mapping. Okay, so what's happening with the mapping for this one? We have to give the mapping situation here. We do have to determine the angle of rotation. So let's go ahead and say clockwise 180 degrees. We already know that. Okay, and then let's go ahead and use our cheat sheet to figure out what the mapping would be for clockwise 180. Okay, so if we look back up here, okay, clockwise 180, okay, we could just use this time. Okay, let's figure out what the mapping would be. So here's x, here's y. Okay, so what did we do? We started off with xy, and we're going clockwise to 180. So if we go down to 180, what happened? Well, we went from 1 to -1, so that's just negative x. And we went from 4 to -4, so that's just negative y. Nothing moved from spot to spot. Okay, I'm going to sort of clear that all there so I don't ruin my little template here. So we had negative x, negative y. So here's our mapping for this one. xy goes to negative x, negative y. So now we can go back down here. Okay, and here's our mapping. xy goes to negative x, negative y. Okay, and that's all it's asking us. Use the coordinate notation. Remember, that's just our mapping to describe it. So we did that. Then determine the angle of rotation. We did that 180 clockwise around the origin. So we're good. Okay, let's head to this one. Okay, use coordinate. I think that's supposed to say coordinate, but I like the name coordinate. So anyway, they want us to show the mapping again to describe it, determine the angle, assume we're going clockwise around the origin. Okay, find the pre-image first. Okay, so here's our pre. Here is our regular image. Okay, and so let's think about what's happening here. Okay. One of the things I like to look at is here's my origin, here's my B. So think about those spokes coming out from the origin. Do we have B coming out from here? Yeah, we do. Okay. We have nothing in this space, nothing in this space. Okay. So it's just a good way to see like how far we moved. Okay. We're going clockwise. Okay. So I'm just like doing some analysis. We have B touching a spoke in this space, so we've only gone one section, which is 90 degrees, okay? And we're going clockwise, so I can take care of that first. Clockwise, 90 degrees. So that's my first exploration. Now we need to come up with the mapping. So clockwise 90 degrees, well, what's the mapping on that, okay? Let's try to do this without looking for this one, okay? So what are we starting with? Okay, for something like this with B, it doesn't really matter. We can just pick two. Again, I like to just keep using 1, 4, okay, because it helps me see what's going on. So if this is my first one, remember the trick for going 90 clockwise is we just go like this. We put the 4 here, and we write op here. Okay, so this was 0 degrees. This is 90 degrees. So based on that little trick, I can come up with the mapping. So what happened? Well, we always start off with x, y, okay? And what happened when we went clockwise 90? Well, our y went to the x spot, so we put the y there. And what happened to the x that we moved over there? We took the opposite of it, okay? So we were able to create our mapping to describe this rotation and tell the angle. Okay, so lots of little tips and tricks there. Okay, here's your last one, which is an apply problem. And then we're all done with this lesson. I know it was a longer one, but if you're still hanging in there with me, you're doing really well. Okay, all right, before moving furniture in her bedroom, Jasmine made a diagram of the current arrangement. She drew a rectangle ABCD to represent her desk with those specific vertices. She then moved the desk twice. First, she translated it, then rotated it. What's the coordinates of the vertices of the final image after all these transformations were applied? So we obviously have two steps here. We have a translation, remember, as a slide, okay? So translated this, okay? And then, different color, rotated it this around the origin. Okay, so let's go ahead and we definitely want to use some different colors here. I might actually just start off with black, and then I'll go blue and then red to match my highlights a little bit here. So we need to do the desk first. So over 2, up 4, 1, 2, 1, 2, 3, 4. Okay, so here's point A. B is 6, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. C is 6, 1. So right there. And D is 2, 1. 1, 2, 1. So we make that rectangle, so that's sort of nice and easy there. Okay. I'm going to go ahead and connect my points here. Make sure it's locked in there nicely. Oh, I don't really like that one. No, stop. I don't ever use box, and now it's all weird and stuff. Go away, line and box and all that. I don't like the box. Okay, go back to normal good things here. Oh, it's really locking that in, isn't it? Can you move it over where I want? Okay, it's being really difficult with that, isn't it? Okay, I might not do the line for that one then. I might just free draw that one because it's being stupid. There we go. Okay, I just free drew neatly. All right, we got to translate it. 3 units left, 2 units down. Okay, so every point we need to go 3 left, 2 down, 3 left, 2 down. 1, so I'm going to take care of A first. 1, 2, 3, 2 down, 1, 2. So A is now here, but this is A prime, right? 3 left, 2 down. Am I still doing that right? Yep. Okay, 1, 2, 3, 1, 2. Here's B prime. 3 left, 1, 2, 3, 2 down. C prime. And 3 left, 1, 2, 3, 2 down. And D prime. Okay, so this is your first example of seeing the use of prime and double prime, because we're actually moving it twice. Man, it is not liking those vertical lines, is it? Jeez, so bad. All right, so there's the first movement. Now we're going to do the rotation around the origin, okay? So we need to take this image and rotate it around, okay? And so this is going to be a little bit funky here. I would probably recommend flat out just going with our trick of movement, because this is going to be a little bit hard to rotate. I guess another thing you could do, this would be a good one to just rotate your iPad, okay? And if you rotate your iPad 90 degrees, okay, you'll be able to see where the image is, and then you just have to like pay attention and look, okay, and pretend it's a new ordered pair, ignore everything else, and like A, if you can see, is to the right 2 and up 1, okay? And so our new image A, which is going to be red, is over 2, up 1, okay? And so that becomes point A. 1, 2, 1 is A, and it's sharing this point here, okay? And so that's one thing you can do. I would also say when things are really like funky like that, I would just use your mapping like we've done, okay? So for example, if you take a point, okay, we're going clockwise, remember, okay? And so if I pretend we have 1, 4, and this is our 0 degrees, if I want to go clockwise 90, remember the trick is just move this. What are you doing there? Move this to here, take the opposite of X there, and there we go, okay? So for this one, my mapping is XY, and then my Y goes to here, and my X becomes negative X here, Okay, so I would probably just do it with the mapping like this. I sort of find that in a way easier, but I don't know, maybe you like to spin your iPad and read it that way. So we're just mapping, and the rule would be y negative x, and then I can sort of just find my new points. So you can see if I use red here now, okay, point A was 2, 4, and it's really easy for me anyway to map it now. So we now have 4, negative 2 for A prime, and then we have B is 6, 4. So B prime, if we put our y in the first spot, we have 4, negative 6. And then point point C was 6, 1. So C prime, okay, we just move the 1 into the x spot and take the opposite of x, negative 6. And the last one, D, was 2, 1. So D prime has to be, let's see, we move the 1 over and we make the 2 negative. So I don't know, I sort of like that. And now all I have to do is just plot those points. And I'm really like confident in that there. Okay, so A is over 4. And then it says, see, that's sort of weird though. It says, oh, dang it. Oh, stupid me. Oops. I went off of the original ordered pairs, not my new translated desk pairs. I wonder if you caught that or you're just following along with me. What did you do? All right, we got to use I was going to say, like, the A's not matching up. We got to use the new translated desk ordered pairs. So A is, if we swoop over here, over 1 up 2. Okay, so negative 1, 2. A is negative 1, 2. Oh, we are so close to being done. Let me just get all these original ordered pairs. B is, let's see, we go over 1, 2, 3, and up 2. 3, 2. C is 1, 2, 3, down 1. 3, negative 1. And D is negative 1, negative 1. All right, so there's my ordered pairs, and this should work out now. So we got A prime, we've got B prime, we've got C prime, we've got D prime. We got ordered pair spots here. Okay, and then let's just go ahead and follow the mapping here. Okay, so the Y moves to the X spot, and the 1 becomes the opposite. The Y moves to the X spot, the 3 becomes opposite. The negative 1 goes to the X spot, and the 3 becomes opposite. The negative 1 goes to the X spot, and the negative 1 becomes the opposite. Okay, so there we go, following the mapping. There we go, now I can plot the points. Sorry about that. Good for you to see, I suppose. All right, so the first one, over 2 up 1. There we go, that matches. B is 2, negative 3, so 1, 2, down 1, 2, 3 is B. Okay, this is double prime. Okay, C, so I guess I could mark that as double primes. C is negative 1, negative 3. Negative 1, 1, 2, 3 is C double prime. And then D is negative 1, negative 1. Negative 1, 1, I was going to say. Double prime, there we go. All right, and then we can go ahead and connect our points, and we can see the new location of the desk. Okay, so that's your apply problem, also known as a pain in the butt problem. Okay, all right, there you go. We've talked through a lot of stuff there. Hang in there, take your time, lots of information, but this right here is going to be your baby that you want to hang on to. All right, if you have any questions, let me know.